In this problem, it says, use the results from a survey of a simple random sample of 1,146 adults, and among those respondents, 91% rated themselves as above average drivers, and we're going to test the claim that more than 4/5 of adults rate themselves as above average drivers. So in part A, it says, regardless of the conclusion reached from the hypothesis test, could we actually have more than 4/5 of adults be above average drivers? So let's look at a simplified scenario where we have one person in the population who has a driving rating of 0. They're very bad drivers. And then we have 4 people in the population who have a driving rating of 10. So then the population mean would be 0 plus 4 10s, and we divide that by the 5 individuals, and we get 8. So in this case, exactly 4/5 of individuals have an above average driving rating. So here's our average. And there are 4 above and 1 below. And I could, make this so that it was more than 4/5. So what we have to do is have a distribution that is extremely skewed to the left. We have one outlier here. And so that's why having a distribution that's skewed to the left would give us a result, or could give us a result, where more than 4/5 of individuals are above the mean. So that is possible. Now, in part B, it says, if we use the same significance level to test the hypothesis using the p-value method, the critical value method, and a confidence interval, which method is not always equivalent to the other two? So when we use the p-value method and the critical value method, those two methods are always going to give you the same result. P-value, critical value, because it's really just two different ways of looking at the same process. The confidence interval can be a little different. So we're going to say the confidence interval method is not always exactly equivalent to the other two, although it will give you the same determination to reject or fail to reject the null hypothesis. In part C, it says it was stated that we can easily remember how to interpret p-values by saying if the p-value is low, the null must go. So what is it that we're talking about here? All right, let's look at a normal distribution. And the null hypothesis is always going to be, let's say in this case, we're saying that the null hypothesis is that p is equal to 4/5, and the alternative is that p is greater than 4/5. So the value from the null hypothesis, we're assuming that that's in the center there. And then we look at our sample information, and our question is that sample information falling in the distribution close to the value from the null hypothesis? So this is my test statistic. Is it falling close there? And then that would be a case where we had a large p-value. But this is saying if the p is low, the null must go. So if we have a large p-value, then we tend to think that, yeah, that's the null hypothesis. We're not proving it, but we don't want to contradict it. Now, if my p-value is far away from that null, or if the p-value is low, that means my test statistic is falling far away from the value from the null hypothesis. So when the p-value is low in relation to the significance level, so our significance level is going to be here, and our p-value is smaller than that significance level, then we should reject the null hypothesis. And then in the next part, they say if the p is high, the null will fly. So what they're saying there is that if the p-value was large, as I just showed you, then we tend to have more belief in the null hypothesis. And so we would not reject the null hypothesis. And then common significance levels are 0.01 and 0.05. Why would it be unwise to use a very specific number like 0.0438? Because it sounds like you found your sample information first, and now you're just setting a p-value that gives you the result that is what you're looking for. So, so that's what's going on there. So we would always want to choose our significance level before the sampling is done. And actually, now a lot of times in a hypothesis test, people will just report the value of the p-value, and they will not make a conclusion as to whether the null hypothesis was rejected or failed to be rejected, and let the reader come to their own conclusion about what is appropriate for that particular scenario. So we don't want to choose our significance level to match up with our results from the sampling, is what I'm saying there. So that is what that problem is about.